Let's solve some math problems here. So we're given this linear equation here, 2y minus 6x equals 14. And we are asked to solve for the slope. So let's recall the standard form of a linear equation, which is y equals mx plus b. In this equation, m here is our slope. So all we need to do is we write this equation here in this form. So that would be 2y minus 6x equals 14. And then we add 6x to both sides. Okay, this cancels out. Then we have 2y equals 14 plus 6x. Okay. Then we divide both sides by the coefficient of y, which is 2. Okay. So this would be y equals 14 divided by 2 is 7, and 6 divided by 2 is 3x. Then we write this as y equals 3x plus 7. Therefore, our slope here is just equal to 3. Okay, let's solve this other problem here. Given the diagram provided, what is the area of parallelogram ABCD if the height y is 7 and the base x is equal to 5? So this is equal to 5 and this is equal to 7. So using the formula for solving the area of a parallelogram, so the area is just equal to base times height. So area here is just equal to our base, which is x, times our height, which is y, and then we plug in the values. 5 times 7. So our area here is just equal to 35. So the answer here is 35. Okay, let's solve another problem here. Given the diagram of parallelogram ABCD and the measure of A, what is the measurement of angle C? So we're given this angle here, then we need to find this one. So in a parallelogram, angles opposite each other have the same measurement. Therefore, angle A here is just equal to angle C. Given that angle A is equal to 60 degrees, so angle C is also equal to 60 degrees. So the answer is 60 degrees. Okay. In the diagram of parallel lines provided, what is the measure of angle Z? Okay. So when a transversal line intersects two parallel lines, so these are two parallel lines such as this one here, exterior and interior angles are formed. So also formed are pairs of angles called corresponding angles. And a pair of corresponding angles occupy the same relative position and are on the same side, this one, of the transversal. One is the interior while the other is the exterior. And this one, and this one, this one, and this one, and also this one. Okay, from the diagram here, we're given this angle, which is equal to 70 degrees. Okay, this one. And the angle y here. So angle y here and angle 70 are corresponding angles, while angle x and angle z are another pair of corresponding angles. So if we know the value for x, we have the value for z. Inspecting angle x here, we see that it is adjacent to 70 degrees. Okay, so we see that it is adjacent to 70 degrees, and together they form a straight line. So all of the angles on a straight line add up to 180 degrees. Therefore, 70 degrees plus x is just equal to 180 degrees. Therefore, we can solve for our x here. That would be 180 minus 70 degrees. So x here is just equal to 110 degrees. Okay. Then the value for our z is also 110 degrees, since angle x and angle z are corresponding angles. So our answer here is 110 degrees. Okay. Given the diagram of parallel lines, what is the value of y? Okay. So we're given this angle here, which is equal to 113 degrees, and we need to find for the value of y. We know that y here is just equal to this angle here, because they are corresponding angles. So once we find this angle, then we also have the value for our y. Okay, this angle here in 113 degrees, this angle here, form a straight line, and the angles on a straight line add up to 180 degrees. Therefore, let's say this angle is x. 113 degrees plus x is equal to 180 degrees. Therefore, x here is just equal to 180 degrees minus 113. So x here is just equal to 67 degrees. And angle x is just equal to angle y. Therefore, angle y is also equal to 67 degrees. So this is our answer here.